Imagine a song that just absolutely wrecks you. Like the chord progression is devastating, the melody swells perfectly, and it hits your, I don't know, your deepest heartbreak so accurately that it actually brings you to tears.
Yeah, we've all had that experience with a piece of music.
Right, but now imagine the entity that wrote that song has never felt a single human emotion. Like it has never had a heartbeat and was essentially turned on, yesterday.
It's a wild thought.
It really is. Today is July 6th, 2026, and the line between human soul and machine logic hasn't just blurred. Looking at the stack of breaking news in front of us today, I mean, that line has essentially vanished.
It is a profound shift. We're looking at a stack of developments today that prove we are no longer just interacting with localized tools. We're navigating a shared environment with systems that are actively mastering the digital realm, manipulating the physical world, and frankly, completely challenging our definition of creativity.
And that is exactly the narrative arc I want to trace today. Welcome to today's deep dive. For those of you joining us, we aren't just reading the tech news today. We're mapping out the rapidly expanding footprint of artificial intelligence.
Exactly. It's moving fast.
Very fast. We're going to look at how this technology is evolving in very distinct stages. So we're starting with its mastery of our language, moving out into the mud of our agricultural fields, then looking at the ensuing panic to build ethical guardrails, and finally, that attempt to conquer human art.
It's a big journey for one deep dive.
Yeah, so let's jump right in. Our first stop is the digital mind. OpenAI has released GPT-4.5. And looking at the specs, the headline isn't just that it's got more parameters.
Right, which is usually the headline.
Exactly. But the real breakthrough highlighted in our sources is twofold. So first, it has achieved this massive leap in comprehending really nuanced contextual language. And second, it's doing so while requiring significantly less computational power.
Which is an incredible engineering paradox if you really think about it. I mean, historically in the realm of large language models, complexity was directly tied to compute power.
You needed bigger servers.
Bigger servers, massive cooling systems, exactly. If you wanted a model to understand the subtle cultural context of a joke, or say the highly specific tone of a legal document, you had to brute force it. You needed massive, energy-hungry server farms running at absolute maximum capacity just to process that level of context.
Well, let me test a theory on you, because that paradox is exactly what caught my eye. If I'm moving from a system that requires a supercomputer to a system that essentially runs on, well, the computational equivalent of a watch battery, but it's somehow smarter.
Yeah.
That implies a fundamental shift in the architecture. It's like a master chef who knows exactly which 3 ingredients to use, rather than a novice who just dumps the entire pantry into the pot to see what works. Is it that the system is no longer activating the entire neural network for every single query?
You've hit on the exact mechanism driving this efficiency.
Yeah.
It's routing.
Routing.
Right. So instead of forcing every single piece of data through a massive monolithic processor, the system has become incredibly adept at categorizing the intent of a query up front. And then it routes it only to the specific, highly optimized subnetworks necessary to answer it.
Oh, wow. So it's not waking up the whole brain, so to speak.
Exactly. When you ask a culturally nuanced question, it doesn't need to consult its math or coding parameters. It just doesn't. It operates with surgical precision.
Yeah.
And because of that precision, the energy required just plummets.
Okay, so we have this highly efficient, culturally aware translator that doesn't need to be tethered to a multi-billion-dollar data center. Let's ground this for the listener. Why does dropping the computational overhead completely change the game for the average person? Because to me, it sounds like we're moving from a centralized utility to something vastly more personal.
It spells one word: democratization.
Democratization, okay.
Yeah, because when a model requires less compute to perform highly complex, nuanced tasks, it completely severs the umbilical cord to the cloud.
Oh, right, because you don't need a constant internet connection to a supercomputer.
Exactly. It means these models can run locally, on your phone, in your car, or in embedded sensors. High efficiency, combined with its global language adaptability, turns this from a luxury restricted to enterprise tech companies into a versatile background utility.
It's just everywhere.
Everywhere.
Oh.
We are looking at a future where smooth, intuitive, latency-free human-machine interaction is just the default state of every digital interface on the globe.
Which opens up a fascinating and honestly slightly terrifying door.
Oh, absolutely.
Because if we no longer need massive servers to run these highly capable models, like if the brain can now fit into small, low-power hardware, then you can take that brain out of the digital ether and put it into a physical machine.
Right into the real world.
Yes. Which brings us to the second major development in our sources, MIT's new AgriBot.
Right. We move from the mastery of the digital mind to the execution of the physical hands.
According to the research brief, AgriBot is this advanced robotic system designed to autonomously manage agricultural fields. We're talking about a machine equipped with sophisticated sensors and machine learning algorithms that monitors crop health, predicts agricultural yields, and this is the part that genuinely gave me pause, manages pest control autonomously.
Autonomously being the key word there.
Exactly. The stated goal here is increasing farming efficiency, sustainability, and securing the global food supply. It's like a Roomba, but instead of vacuuming my living room, it's managing the global food supply.
Yeah, it is a prime example of edge computing in action. AI is now solving earthly, physical problems in real time, completely disconnected from a server farm.
But let's look at the mechanics of that autonomy, right? Because my Roomba gets stuck on a rug. Up until now, if I understand the agricultural tech landscape, AI was mainly a predictive tool.
Right, it gave recommendations.
Right, like a farmer uses a drone to survey a field, an algorithm flags a potential aphid infestation, and then the human farmer decides whether or not to spray pesticides. The human is the final point of friction.
They pull the trigger.
Right. But with AgriBot, the source explicitly uses the phrase autonomous pest control. It's out there making life and death decisions on its own. And, I mean, distinguishing between a harmful pest and a crucial pollinator, like a honeybee, might be easy in a sterile lab. But doing it in a muddy field during a rainstorm,
It's incredibly difficult.
a false positive there isn't just a glitch. At scale, it's an ecological disaster. How comfortable should we be letting machine learning algorithms make those kinds of decisions?
Well, your skepticism is entirely warranted. And it really highlights the massive stakes of moving from predictive AI to prescriptive autonomous action. But let's examine why engineers are pushing forward despite those edge cases.
Okay, why the push?
The mechanism here relies on highly advanced computer vision that assesses threats on a micro level. Think about traditional pest control. It's essentially a blunt instrument.
Crop dusting.
Exactly. Crop dusting entire fields with chemicals, which destroys the soil microbiome and kills both pests and pollinators indiscriminately.
It's the sledgehammer approach.
It is. It's totally the sledgehammer approach. AgriBot shifts the paradigm to targeted micro-interventions. The algorithm identifies a specific threat on a specific leaf and neutralizes only that threat, maybe with a microdose of a targeted agent or even a mechanical action. The reason we are willing to risk the autonomy is because the alternative blanket chemical destruction is fundamentally unsustainable for a growing global population.
So it's a calculated trade-off.
Exactly. A calculated trade-off to secure the global food supply.
Okay, I follow the logic of the trade-off. But if a robot makes a localized decision to neutralize something in a field, or, going back to our first topic, if a hyper-nuanced language model mistranslates a critical diplomatic document, the question of liability becomes incredibly murky.
It's a huge issue right now.
Right. Who goes to jail when the algorithm gets it wrong? The lack of clear oversight naturally forces us to ask about the rules. And reading through our third source, that lack of clarity explains the absolute urgency we are seeing at the recent conference in Geneva.
Yes. The Geneva gathering was entirely focused on the guardrails. We're seeing tech leaders, ethicists, and policymakers just scrambling to establish AI ethics and governance frameworks that can actually keep pace with physical deployment.
Right. And looking at the digest from the summit, they're demanding transparent AI systems, robust frameworks to maintain ethical standards, and this was a big focus, a massive emphasis on the need for diversity in AI development teams to prevent bias.
Which is arguably the most critical point they made.
Well, I have to challenge the corporate jargon in this dispatch a bit, because transparency sounds fantastic on a slide deck. Everyone nods along to robust frameworks in a boardroom.
Yeah.
But how do you actually enforce transparency on an algorithmic black box that has billions of parameters and is teaching itself on the fly? You can't just lift the hood.
No, you can't. And you've identified the exact bottleneck in current governance.
Yeah.
You cannot easily audit the inner workings of a complex neural network once it's fully compiled. It is simply too vast.
It's just math happening in the dark.
Basically, yeah. Therefore, The regulators in Geneva are realizing that if you cannot fully audit the output, you have to rigorously audit the input.
The input,
And the
okay.
most critical input isn't just the data, it's the human beings designing the parameters of the model.
Which brings me to the point I really want to dig into. The source specifically points to diversity in the development team as the critical antidote to AI bias. I really want to understand the actual mechanics of that,
Sure.
because why isn't bias just a data problem? Like, if you feed the machine a perfectly balanced data set, shouldn't the output be balanced, regardless of who is typing on the keyboard?
Well, because there is no such thing as a perfectly balanced data set in a vacuum.
Yeah.
Data is curated. The humans building the machine decide what constitutes ground truth. Let's look at how algorithmic bias practically manifests. If a development team is highly homogeneous, say they share the same cultural background, socioeconomic status, and educational pedigree, they will unknowingly optimize the model for their own worldview.
Because it's all they know.
Right. To them, their specific slice of reality just looks like normal data.
Give me a concrete example of how that plays out.
Think about early voice recognition systems.
Oh, yeah.
They completely failed to understand certain dialects. Or look at medical diagnostic AIs trained exclusively on data from Western hospitals. They ended up misdiagnosing patients from different demographics. The engineers didn't intentionally code those failures.
It wasn't malicious.
No, not at all. The failures occurred because the team lacked the diverse lived experiences necessary to look at the training data and say, wait a minute, this data set represents a tiny fraction of the global population.
So the blind spot isn't a personality flaw, it's literally an engineering flaw. If you are deploying GPT-4.5 to be a global, universally accessible utility, or if you're putting AgriBots in fields across different continents, a homogeneous team is essentially shipping a product with massive, hard-coded technical failures.
Precisely. And this is why the Geneva Conference elevated diversity from what used to be a public relations initiative to a strict engineering and technical necessity.
It's quality assurance.
It's the ultimate quality assurance. If this technology is going to determine crop yields or translate sensitive medical conversations or process loan applications globally, the development team must reflect the broad spectrum of human experience. The humans building the machine have to act as the primary defense against the machine, internalizing our historical biases.
Man, okay, so we've traced the logic here. We've established the digital processing power of these language models. We've looked at the massive implications of autonomous physical labor in our fields. And we've dug into the engineering reality of why we need diverse human oversight to keep these systems ethical and safe.
We've covered a lot of ground.
We have. But all of that implies a world of rigid rules, right? Data points, optimization. What happens when we ask this technology to step outside of logic? What happens when we ask it to be creative?
Well, then we cross the threshold from optimization into human expression.
And that brings us to our final source today, which covers a fascinating and highly controversial collaboration. A renowned music producer has teamed up with an AI company to release an album composed entirely by AI.
Yeah, this is making waves.
And I want to be clear here for you listening. The source notes this isn't an album that was just mixed by a machine or mastered by an algorithm. The actual compositions, the melodies, the chord progressions, the underlying musical architecture were generated by the AI.
It's entirely machine-born.
Right. The project is billed as pushing creative boundaries by blending machine generation with human artistry. And predictably, music purists are up in arms.
Which makes sense because it forces a reckoning with what we consider uniquely human. We have historically treated art, and music specifically, as a protected sanctuary. We tell ourselves that, sure, while a machine can calculate a spreadsheet or identify a bug on a crop, it cannot understand the human soul.
Well, let's unpack how an AI actually writes a song, because I think the how really informs the philosophy here.
Okay.
An AI doesn't feel heartbreak, doesn't have a childhood. What it does have is an unfathomably massive database of every song ever recorded. It understands the mathematical structure of emotional resonance. Like, it knows that a minor fall and a major lift, historically, produces a dopamine response in a human listener. It understands the vector space of audio.
That is exactly the mechanism. It is using predictive analysis to synthesize arrangements of frequencies that humans have historically categorized as moving or beautiful.
Right. Which makes me picture the dynamic in the recording studio. The AI acts as the ultimate tireless session musician. It can instantly generate a bossa nova beat, layer it with a melancholic cello, and transpose it to a different key in microseconds.
It never gets tired.
Never. And the human producer is essentially sitting in the director's chair, listening to these outputs and saying, no, that's too upbeat. Make it darker. Give me more tension.
Which is why the source explicitly emphasizes the blending of machine-generated compositions with human artistry. The human hasn't been removed from the process. Their role has just fundamentally shifted.
But I want to push back on that and throw a deeply philosophical question at you.
Go for it.
The purists in the article are arguing that this isn't real art because it lacks human intent. But let's say you were driving home, you turn on this album without knowing it was composed by a machine, and the music absolutely moves you. The chord progression hits you, the melody swells, and you genuinely start to cry. Does it actually matter that a machine wrote it? Where does the emotion actually live? Does it live in the creator's intent, or does it live entirely in the listener's ear?
Oh, that is the defining question of this entire technological era.
Right.
Yeah.
Because the purists argue that art is a transmission of lived experience. If there is no human suffering or joy behind the composition, they view it as an empty simulation. Just a parlor trick using math to hack human biology.
But humans are meaning-making machines.
Mm.
If I look at a beautiful mountain range or a sunset and it moved me to tears, that sunset didn't have intent.
No, of course not.
It's just light refracting through atmospheric dust. Yet my emotional response is completely valid. Why do we demand intent from a song, but not from a landscape? That is a brilliant way to frame it. And it really explains why the producers behind this project are embracing the technology so fully. They recognize that the AI is simply a new landscape of sound.
A landscape of sound. I like that.
Yeah, the AI generates the raw mathematical possibilities of music, thousands of variations in an instant. But it still requires the human producer's humanity to sift through that endless noise, stop at one specific arrangement and say, that specific arrangement of notes makes me feel something.
So the human becomes the editor.
Precisely. Just as the invention of the synthesizer or the drum machine didn't destroy music, but rather expanded the palette of what an artist could create, AI is functioning as a new, highly complex instrument.
A tool.
A tool, exactly. It doesn't replace the human ear. It relies entirely upon it for validation.
Man, what an incredible through line we've uncovered today. We have traveled a massive distance across the tech landscape.
It really connects, doesn't it?
It does. We started by unpacking the architecture of the digital mind, looking at how the highly nuanced, low-compute processing of GPT-4.5 is democratizing our global communications. Then we moved out into the dirt, exploring the computer vision and autonomous, life-and-death edge computing of AgriBot managing our food supply.
Right. And then we navigated that urgent scramble in Geneva, realizing that as these systems gain autonomy, the only true technical safeguard against catastrophic bias is ensuring the human engineers designing the models represent the full spectrum of the populations they serve.
And finally, we ended up in an AI recording studio, questioning the very nature of human emotion and debating whether a machine can author a piece of music that moves us to tears.
You know, when you look at all of these sources laid out together, a very clear, perhaps unsettling pattern emerges.
What's that?
We're watching artificial intelligence rapidly take over the heavy lifting of our civilization. It's taking over the complex data processing of our language. It's moving into the physical execution of our agricultural labor. It's even generating the foundational architecture of our creative music.
It's doing, the actual execution.
Exactly. Which leaves us with a vital problem. If our machines can fluently translate, autonomously farm, and mathematically compose, what becomes the essential human job of the future?
Wow.
Will our primary role in society shift fundamentally away from being the creators and doers to simply being the curators and ethicists of what our machines produce? Will our main job simply be to sit in the director's chair and guide the output of our algorithms?
That is a staggering thought to leave on. Are we all destined to become the curators of a machine-generated reality? We'll have to let you chew on that one as you go about your day. Thank you so much for joining us for today's deep dive. We covered a massive amount of ground today, but in this landscape, there is always more to learn. Remember to stay curious and keep questioning the future. We'll see you next time.